Good morning, everyone. I am Eleonora from Italy, from the University of Bologna. And this is my talk. And I want to acknowledge the project for which I'm here, which is called Fedora. Fedora is a project, European Horizon 2020 project, which is basically on I will cover some of the issues we are dealing with in the project. And especially it is focused on the so-called future-oriented science education, which is at the frontier now of research in science education. I will deal with it in the presentation. So, the premise. Okay. Great. So the premise from which we have to start when we talk and introduce future-oriented science education is that we live in a society, in the society of acceleration, as the sociologists say. I mean, we have talked about it a lot in these days, and it's not only a matter of change. Our society is not only changing, but what is changing is the pace of change itself, so the acceleration, basically. And in this context of profound uncertainty, what really suffers is also our relationship with the future that becomes problematic and source of anxiety. So instead of a promise, future starts to be seen as a threat. And this is far more true with young people, especially those who are starting to feel marginalized or excluded, and who are struggling with the idea that school is not providing them something meaningful and something that they can perceive as useful also for their position within the world of work. So they are basically struggling a lot, and many reports, international reports, are saying this, in projecting themselves into the future, and so and also in seeing themselves as agents in the present with an orientation toward the future. So this is where future-oriented science education basically starts. And why science education? Because this field, which is very recent, aims at reconstructing the conceptual, epistemological, and methodological structure of science to support students, learners, in recognizing how the present is complex, but via an explicit reflection on the future, explicitly focusing on the future. And we do this by focusing on the nature of science, on the epistemological layers of science and of disciplines. I'm a physicist, but my colleagues are computer scientists, mathematicians, and we are doing it starting from the disciplines. It is necessarily an interdisciplinary field that embeds a lot of perspectives, from the learning sciences to the sciences and STEM disciplines, to also humanities and sociology. And this is a metaphor that became for us in the project, and for me specifically in my research field. This is a metaphor of the future cone, the cone of the future, which comes from the disciplines of futures studies, which contains a plurality also in the name itself. The idea is that we cannot think at time and at future as a sort of line. We start in primary school at seeing history as something linear. We have the past that causes basically the present that will cause the future, and now we have a sort of more expanded way to think about the future in this metaphor of a cone, in which different kinds of futures can be identified as the probable ones, like the closest to the line, the horizontal lines, but then we have also plausible and possible future, which contains all the possibilities. And it's not only a matter of probability, the idea of projecting ourselves into the future. It's also a matter of values and of desires, because the future studies also identify a particular type of future, which is the desirable future, the preferable future, which contains not only projections into the idea of what is more or less probable to happen, but an idea of what I would like to be realized. And why complex systems? Complex systems, really, if we read the literature, as I have studied a lot, the literature in future studies, complex systems is an everywhere metaphor for describing this change in thinking about the future. Because in complex systems, one of the ways to think about complex systems is from an epistemological perspective, this enormous change in terms of causality. We pass from an idea of determinism, which is usually conveyed also by disciplinary learning. Let's think about physics. If we have the laws of motions that are basically grounded on the idea that knowing the present, we will be certain about the future evolution of a system whenever we will look at the system itself. And we pass to another kind of causation that is far more complex and includes, for example, the so-called butterfly effect, so a nice sensitivity to initial conditions of the system, feedbacks, effects, and also emergent properties, on which, we really challenge our understanding of how causality needs to be understood. So our stance is that exploring non-Newtonian, non-mechanistic, non-reductionistic, non-deterministic scientific models can help the students to envision the future in a more open way. To open the corner, to open the line, and following the metaphor before. And actually, complex systems and futures are really are becoming more important also from a political point of view. I don't know if you know this, but in the European Union and in Europe in general, this is becoming like a trend. This is the DREAM-COMP, the competence framework elaborated by the Joint Research Center of European Union, that for the first time embed future thinking and system thinking as important competency to tackle with the sustainability challenges. So this was in some way also a product of the Fedora project, because authors were involved in the project and in the writing of this framework, but it's becoming something very good. And I come to the third, which is part of the title of my presentation, which are future-scaffolding skills. We are studying the effect of our teaching proposals on students, mainly high school students, on their way of imagining and tackling with future challenges and with the very same idea of the future. And we've found two types of skills that can be fostered. Structural skills are those skills that allow to organize knowledge, and in particular organize pieces of knowledge into a systemic view. We are calling structural skills because they build basically the scaffolding of the scaffolding on which the students need also to move through the different levels of the scaffolding. And we come to dynamical skills. That are abilities to navigate across this complexity of knowledge, across this scaffolding in a very complex and way to make sense of knowledge. This is a list of skills. Of course, I can provide you more references and whatever we can talk about this, but some examples. In structural skills, we see skills that involve, for example, the distinguish between some details and the overall picture of the system, to unpack an issue into simple parts, to recognize causal and logical relationships within a complex issue. And in dynamical skills, we have skills that include the ability to move, for example, from locally, globally, thinking locally and thinking globally, thinking at the present and thinking at the future and vice versa, thinking at the individuals and thinking at society. Also creative thinking and approach that balance opposite needs, for example. And it comes to this question, how to teach and learn about complex systems. I'm not here to answer this question. We have seen a lot in these days, but what I can tell you is how I teach complex systems, which is with agent-based simulations. Agent-based simulations, I've taken an example here, is a famous example in Etogo. Both are model. Basically, you have agents with opinion green or blue, and they are influenced by their neighbors. So they vote as the majority of their neighbors, and we observe that starting, for example, from mixed population, we arrive to clusters, basically, and regions of similar votes. And why I chose this example? Because I can show very explicitly that these local interactions among individuals produce changes at the emergent and the global, at the global and macroscopic level. So I chose computational simulations and agent-based simulations because of this idea that they allow to see an evolution, so a time evolution, but they also focus very much on the individual level and the individual role, the role of the individual. So let's go inside the classroom and see what happens. I've designed a module on agent-based simulations. It was an 18-hour module for high school students who participated in a university orientation program. It was not mandatory for them. They decided to enroll in this program. The program basically was included the introduction to the topic of simulations, to see how they are research tools, and we included also lectures on agent-based simulation. But the final activity that we made them do, that we asked them to do, was the so-called future-oriented activity, which is common to many activities we are doing in these years, that asks in group the students to identify a problem which is relevant for them in the present, a societal problem, for example. It can be related to the school, to the environment, to politics. And then we ask them to choose a simulation to explore different futures with this simulation. Of course, this implied a modelization process, because the simulations that they could experience were very, very, very simple. So they had to, downscale their big problem to the features of simulations. Then to imagine a desirable scenario, to put their values on the problem, and to proceed with identifying the actions in the present and throughout time that could have led to that desirable scenario. My research questions are two. First, future-scaffolding skills can be developed. Students can develop future-scaffolding skills through this future-oriented activity, and how? And then, are the students able to verbalize the competencies that they have acquired and that they have put into action? After this, I have not said it, but at the end of this activity, we ask the students to present, basically, their results and their story of success, we called it, and we interview them at the end to see, on one side, if the competencies were exhibited, put into action, and then if the competencies could be verbalized by the student. These are the skills exhibited for groups. In orange, you see the structural skills to construct the scaffolding, and in blue, the dynamical ones. We see that I mean, competencies can be developed, but we observe that in most groups, all but the sixth one, the structural skills are more frequent than the dynamical ones. So constructing, building the scaffolding is easier or more explicitly present than moving across the levels of the scaffolding. This is a good news because it was very, very different than in other studies in which simulations were not used to build the future scenarios and to explore and to model the problem, the issue. And we have an hypothesis for this success because using simulations allowed students, we think, that allowed students both to handle and dive into the complexity of the problem. Handling meaning structuring their analysis of the problem, to identify the issues, to identify the agents, to identify and unpack a complex issue and reduce it into through a modelization process to find agents and modes of interaction that could allow the computation. But at the same time, simulations, for their own nature, include a sort of balancing between opposite trends that are included also in dynamical skills, like focusing at the individual and focusing at the whole emergent global picture of the system. And the emergent picture of the system feedback onto the elementary agents. So these tensions that are included in the dynamical skill, individual, society, also present and future, also are embedded in the very same epistemological structure of simulation. So these are our hypotheses for the success. But when we come to the skills verbalized in the interview, when students are asked, I mean, what did you learn? What competencies did you learn through this module? What competencies did you put into play, for example? We see that on average, structural skills disappear. And we have many more dynamical skills, which is an opposite trend than the skills exhibited during the students' presentation. And if we unpack not only structural and dynamical, but we see the list of all structural and dynamical skills, we see that something is very common between skills exhibited and verbalized. We see, for example, this idea that students recognize that the simulations and the future-oriented activities allow them to recognize multiple aspects of a problem and relationship they could have not been able to see it without this activity, only thinking in general about the problem. And they realize that multiple possibilities can be envisioned, that this plurality of the future was very important for them. But we also observe a misalignment. For example, students in their presentation really put into play these competencies about recognizing the causal structure of a problem. Causes, objectives, results, complexity also of the causes, but then they are not, they seem not to be conscious, aware of these competencies they put into play. And at the same time, for example, they recognize the very high importance of interdisciplinarity and multidisciplinarity way of thinking at the problem that it seems not to be like that in the presentation themselves. So we observed a gap between the skills put into play during the group activity and those perceived and verbalized during the interviews. And on one side, as I said, it was encouraging, this result, because in other experiences, students struggled a lot to develop structural skills and skills of constructing the scaffolding. It was easier for them to construct ways to move from present to the future, to local to global, but the structure of the system was hard for them to be achieved. And in this experience, it was not. But when we asked the students to verbalize this conference, these competence things changed. They seem to lack words to describe the achievement mainly of structural skills, even if they put into play during the group. So in conclusion, we have to conclude that we have to study more, to investigate more about the topic. We have started to do that using also different data collection tools. But for sure, this misalignment between what you are able to do and what you recognize to be able to do is something that is important to investigate, because literature tells us that metacognition is important. You have to understand what you know and how you learn. And so being this competence of self-perception as said, a cornerstone of social and emotional development, we need to, in research, to investigate ways to make students even more active protagonists of their own learning, also identifying which gain they can have from this specific future-oriented literature. Here are some references that I'm happy to provide you. And